Let's do a little more investigation on Young's double slit experiment. And here we're looking at the uh, point at which the two rays come in. There's a distance d that we have, little d, that is the distance of the center lines of these two slits. And in this case, we find that directly behind the screen, the distance is pretty much the same as the waves bend around. And so we get constructive interference at the center point. Now, there are locations where you get a little extra wavelength distance. If we were to draw a triangle here, notice that here you have a wavelength extra. And so in that case, the wave peaks will match, and when I get up to this point, I have a bright spot, even though that there's a certain angle that is occurring here, this theta. And this theta then gets translated to, this theta gets translated to this theta as similar triangles. But also, there's a point at which you get half wavelengths, and if half wavelengths occur, then you get destructive interference because the two waves are canceling each other out. And that happens when you have half wavelengths, just like we talked about in chapter 15. So it really depends on this distance, what we call S1 minus S2, as to whether I have wavelengths or half wavelengths. And this distance is just equal to the sine of the angle theta times the distance between the two slits. So we can sum this up for constructive interference. We have d, the distance between the slits, sine theta is equal to m times lambda. And for destructive interference, we have d sine theta is equal to, and here it's going to be m plus 1/2 to account for the half wavelength difference that we need, times lambda. Now the m value is related to how the light bands match up on the screen. So if we notice in this picture, the height represents the intensity or brightness of the band. So for constructive interference, we have m starting at 0, and on either side you're going to have bands that correlate to these different m values, with 0 being the strongest peak. For destructive interference, notice that the m value has 2 zeros on the bottom because of the plus 1/2, and each of these points then will have the destructive interference or black lines on the pattern, on the diffraction pattern. So Young's double slit experiment, we can calculate where these slits are going to be based on the trigonometry of the setup of the double slits and the distance to the screen.